Second one that was asked about was number 13. Number 13 starts out like this: the integral of dt over 1 minus secant t. And I know that what I don't want on the bottom is I don't know what to do with 1 minus secant t, and so I want to get rid of that. So I multiply by the conjugate here. 1 plus secant t over 1 plus secant t. Now why do I do that? Well, lots of years of doing this for one thing, but also what I see is that if I'm going to have a 1 and a secant somewhere, I'd rather have 1 and secant squared, because I know there's this relationship between sine squared plus cosine squared equals 1, and if I divide through by cosine squared there, I get 1 plus tangent squared equals cosine squared, or equals secant squared, etc. So that's what I'm trying to do, is modify the denominator so it doesn't look like this. So what I end up with then is 1 plus secant t times dt. And the bottom here, first times first gives me 1. Outer gives me secant. Inner gives me minus secant. Those go away. And I have minus secant squared t. Now, that's what I was looking for, because of the fact that, if we start with cosine squared t plus sine squared t equals 1, and if I divide through by cosine squared t, what I do, cosine squared over cosine squared is 1, sine squared over cosine squared is tangent squared, and 1 over cosine squared is secant squared. And what I see right there is if I was to rearrange this thing, then I can subtract secant squared from each side and tangent squared from each side, and this would be true. So the denominator that I have there, I'm going to change into tangent squared, or my negative tangent squared, which I'm just going to bring the negative outside my integral. There's a dt in here, I'm running out of space, over tangent squared. Now, why is that good? Well, if my board doesn't fall off the chair. Okay, so now I'm going to break that into two separate integrals, one of which is I'm going to bring the minus out of the whole thing and say one of them is the integral of 1 over tangent squared t dt. That's just 1 over this. And the second one is secant t over tangent squared t dt. The good news about this is I have simple denominators rather than having two pieces, and so based on that, it makes life a little bit simpler. Okay, what do I do with that? Well, now I look at this and I say, well, 1 over tangent squared t, well, 1 over tangent is cotangent, so this is just the integral of cotangent squared t dt. I've gotten rid of the fraction altogether. I'm very happy about that. I don't know exactly how I'm going to deal with that yet, but I will deal with that. Over here, the secant over tangent squared, I look at that and I say, well, this would be a lot simpler. All of those can be written in terms of cosines and sines, and so I'm going to convert everything into cosines and sines. Secant would be 1 over cosine. Tangent squared is sine squared over cosine squared. And if we think about 4-story fractions, the first and fourth story multiply together, the second and third story multiply together, and the first and fourth go on the top. I'm going to end up with a cosine squared on the top and a cosine times sine squared on the bottom. So this is going to cancel with this. And just looking at only that second term for right now, that's going to become cosine t over sine squared t, which, again, just focusing on that term, I can write that as the integral of sine to the minus 2t cosine t dt. And that's a good place to be, because now if I let sine be u, I've got u to a power, and cosine t is dt. So I'm going to leave that alone for a minute. But I'm going to get back over here and look at this, and this cotangent squared. We're using that same idea that I did before. Sine squared plus cosine squared equals 1. If I divide through by sine squared instead of dividing by cosine squared as I did before, that would give me 1 plus cotangent squared t equals cosecant squared t. And I have cotangent squared t here. So that means that cotangent squared t is equal to cosecant squared t minus 1. So I'm going to replace that thing with cosecant squared t minus 1. Still have the negative sign. Integral, now I have an integral of two things. I have the integral of cosecant squared t dt minus the integral of 1 dt. That's what that breaks into. Again, I'm going to continue pursuing this over here. The integral of cosecant squared, well, if you remember, the derivative of cotangent is just negative cosecant squared. So this is going to integrate to negative cotangent. And that integral is done. I'll have to distribute a negative sign, etc. in a minute, but that's done. Here, I integrate 1. That's just t. So I have that. Over here, I still have a little bit more work to do. I have to say, let u be sine of t. du dt is cosine t. And therefore, dt is du over cosine. And if I make that substitution in here, I've got u to the minus 2. Cosine t dt is du over cosine t. Those go away. And I'm really out of board space, but what that's going to integrate to, and I'm just going to squeeze that over here, I'm going to raise that power by 1 and divide by it. So I raise that power by 1, it's u to the minus 1, divide by minus 1, and so that's been done separately. This is my entire thing here. I'm going to distribute that minus sign. It's going to make this cotangent t. It's going to make this plus t. And this negative is going to wipe out the minus 1 that's there. So then I'm going to have just 1 over u. And u was sine t. So that should be what I end up with on that integral. And I see that I've cut off the bottom, so that's lovely. I need to cut off the bottom and the top. There, now you can see it, I hope. And gives you cosine t plus 1 over sine t.